Download this code from codegive.com, link in the description below. OK, let's dive deep into performing CRUD, create, read, update, delete, operations using material table, or material table, with Material UI. This tutorial will provide a comprehensive guide with code examples and explanations. We'll assume you have a basic understanding of React and Material UI. Conceptual overview. Material table is a powerful React component that simplifies the display and manipulation of tabular data within your Material UI applications. While it provides UI elements for CRUD operations, you need to connect it to a backend, API, to actually persist and manage the data. This tutorial will cover the front-end, material table, aspects, with notes on how to integrate with an API. Prerequisites. *node.js and npm, or yarn. Make sure you have node.js installed, which includes npm, Node Package Manager. Yarn is an alternative. *React environment. You need a React project set up. You can create one using Create React App. Material UI and Material Table. Install the necessary packages. Step-by-step guide. 1. Project setup and basic Material Table implementation. First, let's create a basic React component that utilizes Material Table. Create a file named table component.js, or similar, in your src folder. Explanation. Imports. We import Material Table and the necessary Material UI components, especially icons. Table icons object. This is crucial. Material Table uses icons for actions like add, edit, delete, etc. You need to map these to the Material UI icons. The forward ref is important for passing refs correctly to these components. We import all needed icons. Uses tate hooks. Data holds the table data. Initially, it's populated with 2 example user objects. This is where your data fetched from your API will reside. Columns defines the structure of the table. Title is the column header, and field is the key in your data objects that corresponds to that column. Editable never prevents editing a specific column, example the ID. Material Table component. Title, the title of the table. Columns, the column definitions. Data, the table data. Icons, assigning the table icons object to use customized icons. Editable, this object defines the CRUD operations. We'll break down each operation in the next sections. Actions defines custom actions that appear in the table toolbar. Here, we've added a refresh button for demonstration. Read operation, initial data load. The read operation is already implemented in the initial setup. The data state variable holds the data that's displayed in the table. Fetching data from an API. In a real-world scenario, you'd replace the initial data with data fetched from a backend API using useEffect. Key changes. Uses tate is initialized with an empty array, uses tate. useEffect hook, this hook runs after the component mounts. Fetch data function, this async function fetches data from an API, replace the example URL with your actual endpoint. Data mapping, the map data part is crucial. Ensure that the data structure returned by your API matches the field names defined in your columns array. If the API returns first name instead of name, you need to map it accordingly, name, user.firstname. Error handling, the try, catch block provides basic error handling. Empty dependency array, use effect is called only once on mount because of the empty array. If you pass other variables into that array, use effect will trigger if any of those variables change. 3. Create operation, adding a new row. Material table provides the onRow add prop within the editable object to handle row creation. Explanation. *onRow add, this function is called when the user clicks the add button and saves the new row. It receives new data, which is an object containing the values entered by the user in the new row. *promise, the function must return a promise. This allows material table to handle the asynchronous nature of API calls, waiting for the server to respond. *set timeout, this is used to simulate the latency of an API call. Remove this in a real implementation. *API call, important, replace the commented out example fetch code with your actual API call to create the new data in your backend. The fetch call should *use the post method. *set the content type header to application/JSON. *send the new data, converted to JSON using JSON.stringify, in the body of the request. *handle the response from the API. If the creation is successful, the API should return the newly created object, including any server-generated IDs. Update the data state with this object. *handle errors appropriately, using catch. Call reject, to signal to material table that the operation failed. *local update, demonstration. For this example, we simulate ID creation and update the data state directly. This is only for demonstration purposes and should be replaced with the API call in a real application. *resolve, call resolve, when the operation is successful to tell material table to update the table. 4. Update operation, editing an existing row. The onRow update prop within editable handles row updates. Explanation. *onRow update, this function is called when the user edits a row and clicks the save button. It receives new data, the updated row data, and old data, the original row data. *promise, again, a promise is required to handle the asynchronous API call. *set timeout, simulating API latency. *API call, important, replace the commented out fetch code with your actual API call. *use the put or patch method, depending on your API. Put typically replaces the entire object, while patch updates only specific fields. Send the new data in the body of the request. The API should return the updated object. Update the data state with this object. Handle errors and call reject, if necessary. Local update, demonstration. We find the index of the row to update and replace it in the data array. Resolve, call resolve, to signal success. 5. Delete operation, deleting a row. The onRow delete prop handles row deletion. Explanation. onRow delete, called when the user clicks the delete button. It receives old data, the row data to be deleted. Promise, asynchronous operation. Set timeout, simulated API latency. API call, important, replace the commented out fetch code. Use the delete method. Check the response status from the API. A status code of 200, OK, or 204, no content, usually indicates success. If the deletion is successful, update the data state by removing the deleted row. Handle errors and call reject, if necessary. Local update, demonstration. We find the index of the row to delete and remove it from the data array using splice. Resolve, signal success. 6. Integrating the table component into your app. In your app.js file, or wherever you want to use the table, import and render the table component. Important considerations and best practices. Error handling. Implement robust error handling in your API calls. Display error messages to the user if operations fail, example using a snack bar or alert. Validation. Validate user input on the front end and the backend. Material tables. Editable fields can be customized with validation rules. Optimistic updates. Consider using optimistic updates for a better user experience. Optimistically update the UI before the API call completes. If the API call fails, revert the changes. Loading indicators. Display loading indicators, example a spinner, while waiting for API responses. Material table has a is loading prop you can use in your custom actions. Backend implementation. This tutorial focuses on the front end. You need to create a backend API using node.js, Python, Flask/Django, Java, Spring Boot, or any other language/framework to handle the actual data persistence and business logic. Security. Protect your API endpoints with authentication and authorization to prevent unauthorized access and data manipulation. State management, optional for larger applications. Consider using a state management library like Redux or Zustand to manage the table data and API interactions more effectively. ID management. If your backend handles ID generation, make sure to use the IDs returned by the API when creating new rows. Avoid generating IDs on the front end. The backend is the source of truth. Data structures. Ensure consistency between the data structures used on the front end and backend. Refresh data. The refresh button in Actions can be used to manually refresh data. It might be helpful to call fetch data within the onClick to reload. Filtering and sorting. Material table provides built-in filtering and sorting capabilities. You can customize these features to integrate with your backend API for server-side filtering and sorting. Table data. Material table adds the property table data into each row's data object. It contains the ID, which is the index of the current row. This is not the actual ID from the database or API, but the ID you define in the data itself. Custom icons. You can replace default icons for any icons that you may want, for example edit, delete, or add. Example API integration, illustrative. Let's assume you have a node.js/express backend API with the following endpoints. *get/API/users, returns a list of users. *post/API/users, creates a new user. *put/API/users/ID, updates an existing user, by ID. *delete/API/users/ID, deletes a user, by ID. You would modify your table component.js to use these endpoints in the CRUD operations, as shown in the commented out code examples. Complete example, with comments about API integration. Key improvements. API URL. The API URL variable stores the base URL for your API. Error handling. The fetch calls now include error handling to check if the response status is OK, 200 to 299. If not, an error is thrown. Handle row add, handle row update, handle row delete functions. These functions are now async and handle the API calls for each CRUD operation. They also handle errors and update the state accordingly. Promise handling. The editable properties now use these dedicated async functions, which return promises. This allows material table to wait for the asynchronous operations to complete and handle any errors appropriately. Rejection of promises. The throw error statements in the catch blocks ensure that the promises are rejected if there are errors during the API calls. This